this session we shall deal with problems on trigonometric ratios. Problem number 1. If ABCD are the angles of a cyclic quadrilateral, then cos A plus cos B plus cos C plus cos D is equal to, first option 0, second option 1, third option -1, fourth option 2. What do you mean by a cyclic quadrilateral? A quadrilateral that can be inscribed in a circle. Such a quadrilateral which can be inscribed in a circle is called a cyclic quadrilateral. In a cyclic quadrilateral, sum of the opposite angles is equal to 180. That is, opposite angles are supplementary. Angle A plus angle C is 180. And similarly, angle B plus angle D is also 180. So when it comes to cos A plus cos B plus cos C plus cos D, what is it you can say about this? The C can be written as 180 minus A. So cos A plus cos B plus this we can write it as cos of 180 minus A, and this D we can write it as 180 minus B. So cos of 180 minus B. What do you know about cos 180 minus A minus cos A? So this minus cos A, this becomes cos A plus cos B, and here we have minus cos A, cos of 180 minus B minus cos B, so that makes it 0. Cancel and we have 0. So in a cyclic quadrilateral, what is it we know? The opposite angles are supplementary. So A plus C is 180. So C can be written as 180 minus A. Cos of 180 minus A we know is it equal to? It is equal to minus cos A. So we have repeatedly applied that, and therefore the answer is 0. That is appearing in the option 1. Option 1 is the answer. Let's move on to the next question. Question number 2. If ABC are the angles of a triangle such that angle A is obtuse, then first option tan A into tan B is less than 1, second option tan B into tan C is less than 1, third option tan C into tan A is less than 1, fourth option tan A into tan B into tan C is less than 1. Let's look at this. We have a triangle ABC, out of which angle A is known to be obtuse. This is obtuse. In a triangle, so this 2 will have to be acute then. You can have only one obtuse angle, so these two have to be acute. Both angles B and C must be acute. Now tan of an obtuse angle, that is tan of an angle which lies between 90 and 180, has to be negative. So tan A is negative, we know. Okay, but what is A? We know that A can be written as 180 minus of B plus C, because A plus B plus C is 180 in a triangle. Okay, so what we can do here is tan of 180 minus of B plus C is negative, which gives me minus of tan of B plus C is negative. So this implies tan of B plus C has to be positive. But what do you know about tan of B plus C? We know tan of B plus C is equal to tan B plus tan C by 1 minus tan B tan C. So this has to be positive. We already know that B and C are acute. B and C are acute, so tan B comma tan C are both positive. Acute angles, tangent has to be positive. So the numerator has to be positive. When can a fraction be positive? When both are of the same sign. So that means what? This implies 1 minus tan B into tan C also must be positive, which clearly implies that tan B into tan C is less than 1. Tan B into tan C is less than 1. So what we can infer from here is that tan B into tan C is less than 1, and that is clearly appearing in the option 2. Option 2 is right. Option 2 is right. Let's move to the next question. If y is equal to secant square theta plus cos square theta, theta not equal to 0, then y is 0, first option. Second option, y less than equal to 2. Third option, y greater than equal to 2. Fourth option, y strictly greater than 2. Here, let's have a look here. Secant square theta plus cos square theta. This we can write it in the form of 1 by cos square theta plus cos square theta, which we can further write it in the form of cos theta minus 1 by cos theta, the whole square, plus 2. Because when you expand this, you get cos square theta plus 1 by cos square theta minus 2 cos theta into 1 by cos theta, that will make it minus 2. I am adding and subtracting a 2 for here. So what I do is, I am subtracting a 2 and adding a 2. This is becoming a perfect square now. Cos theta minus 1 by cos theta, the whole square, plus 2. Now this is a non-negative quantity. Square of a real number is non-negative. Therefore, this is actually greater than or equal to 2. Now this is our y. When can equality hold good? When this becomes 0. So y equal to 2 happens if and only if y can be equal to 2 only if and only if cos theta is equal to 1 by cos theta. That means theta has to be 0. Alright, theta has to be 0. But theta is, okay, this would imply that theta has to be 0. But theta is given to be non-zero. So cos theta cannot be equal to 1 by cos theta. So this cannot be equal to 0, which means that we cannot have this to be this theta, I mean y to be 2. Therefore y has to be greater than 2 only. Y equal to 2 cannot happen, although that is also a correct option, because when you say y greater than or equal to 2, y could be greater than 2 or equal to 2. Any one of them is happening, that option is taken to be correct. But since he has given already a strict inequality, so we should go for that option, because the equality can hold good only when cos theta becomes 1 there, and theta is non-zero, therefore cannot be happening there. So therefore the answer is option 4. Let's move on to the next question, question number 4. By eliminating theta from the equations, a secant theta plus b tan theta is equal to c, comma, b dash tan theta minus a dash secant theta is equal to c dash, then cb dash minus c dash b the whole by ab dash plus a dash b the whole square minus ac dash plus a dash c by ab dash plus a dash b the whole square is equal to, first option 0, second option 1, third option 2, fourth option minus 1. We are given the equations a secant theta plus b tan theta is equal to c. So we'll write it as minus c equal to 0. Now the second equation is written like this: minus a dash secant theta plus b dash tan theta minus c dash is equal to 0. Let's write it like this. So let us write like this. Now here we got to eliminate theta, so let's find out secant theta and tan theta. We'll write the cross ratio formula. So what do we have the coefficients to be? A, B and minus 1 minus c. What do we have here? Minus a dash, b dash and minus c dash. Let's use the cross ratio formula. Secant theta by minus bc dash plus b dash c is equal to tan theta by plus A dash C plus AC dash. Okay, and 1 upon AB dash plus A dash B, using the cross ratio formula here. Secant theta, when I am writing secant theta by minus BC dash minus of minus, so I will get plus B dash C, tan theta upon A dash C plus A dash AC dash, 1 upon this. So what is secant theta? Secant theta will be B dash C plus minus B C dash divided by AB dash plus A dash B. What about tan theta? Tan theta will be A dash C plus AC dash by AB dash plus A dash B. What do you know? How can you eliminate theta from these two equations? We know that secant square theta minus tan square theta is equal to 1. Secant square theta minus tan square theta is equal to 1. So that's how we can eliminate theta and write an equation in this coefficients A, B, C, A dash, B dash, C dash. And what is that coming out to be? B dash C minus B C dash by A B dash plus A dash B the whole square minus A dash C plus AC dash by AB dash plus A dash B the whole square is equal to 1. So this is what you required. What we were asked was CB dash minus BC dash by AB dash plus A dash B whole square minus AC dash plus A dash C by AB dash plus A dash B the whole square is what we wanted, and that's clearly 1. Therefore the option 2 is the right answer. Option 2 is the right answer. Let's move on to the next question. Question number 5. Secant theta minus tan theta is equal to 3. Theta lies in the quadrant. Options are first quadrant, second option, second quadrant, third option, third quadrant, fourth option, fourth quadrant. We know that in the quadrants, first quadrant, if theta lies in the first quadrant, all the trigonometric ratios are positive. Here sine and cosecant are positive. Sine and cosecant are positive. Here tan and cot are positive. And here we have cos and secant, cosecant are positive. Sine and cosecant are positive. Here cos and secant are positive here in this quadrant. Now use this now. Secant theta minus tan theta is equal to 3. Now secant theta plus tan theta will be equal to 1 by secant theta minus tan theta, because secant square theta minus tan square theta is equal to 1 for us. So this has to be 1 by 3. So we can generate one more equation here. Now adding these two secant theta is equal to 3 plus 1 by 3. That gives us 10 by 3. So this gives us secant theta to be equal to 5 by 3, which in turn implies cos theta is equal to 3 by 5. Cos theta is 3 by 5. So it could lie in the first or fourth quadrant because cos is positive. In the first and fourth, cos is positive. So now we need to decide upon whether this lies in the first or fourth quadrant. Theta lies in first or fourth quadrant. But then we have to look at some other thing now. Okay, let us see. What is it you observe? Let us subtract one from the other. Now 2 tan theta, if you go for, what is that? Second equation minus the first equation. Second equation minus first equation will give us 2 tan theta. And what is that equal to? 1 by 3 minus 3. That is minus 8 by 3. Which gives us tan theta to be equal to minus 4 by 3. That gives me that tan theta is negative, whereas cos theta is positive, tan is negative here. So, I mean all the trigonometric ratios will be positive in the first quadrant. So, tan also would have been positive there, but you are getting tan to be negative. So, that cannot happen in the first quadrant. So, it can only happen in the fourth quadrant. Therefore, the right option is theta lies in fourth quadrant. In fourth quadrant. Theta lies in the fourth quadrant, and therefore, the option 4 is the right answer. Option 4 is the right answer. Okay, let's move on to the next question. Question number 6. If sin theta is equal to 2ab by a square plus b square, then secant theta plus tan theta is equal to, first option, a minus b by a plus b. Second option, a plus b by a minus b. Third option, ab by a square plus b square. Fourth option, ab by a plus b. Now, sin theta is opposite by hypotenuse. So, this is theta. We will write this as 2ab. A square plus b square, because we are given that sin theta is equal to 2ab by a square plus b square. So, let us use a right angle triangle and find out the values of secant theta and tan theta and substitute. So, what do we get here? We get here a square plus b square minus 2ab the whole square under root will be this. So, that gives us, that clearly gives us, okay, a square plus b square whole square minus 2ab the whole square will be what you get here, and that will be clearly a square plus b square the whole square minus 4a square b square under root. It's like something like x plus y the whole square minus 4xy, that comes out to be x minus y the whole square. So, this turns out to be a square minus b square the whole square under root, which is nothing but mod of a square minus b square. Let us assume that a is greater than b. Let us assume a greater than b, because okay, we do not have an option with b minus a there. So, let us assume a greater than b. Therefore, this I can write in the form of a square minus b square there. Now, what is secant theta? Hypotenuse by adjacent. So, that comes out to be a square plus b square by a square minus b square. Okay. What about tan theta? Tan theta comes out to be 2ab by a square minus b square. So, when you add these two, secant theta plus tan theta, that gives us a square plus b square plus 2ab by a square minus b square, which we can write in the form of a plus b the whole square by a square minus b square. That gives me a plus b by a minus b. So, the right option is option 2 is the right answer. So, let us move on to the next question. Question number 7. 3 into sin x minus cos x raised to the power 4 plus 6 into sin x plus cos x the whole square plus 4 into sin power 6x plus cos power 6x is equal to, first option 3, second option 6, third option 4, fourth option 13. If you look at the options here, all the options are independent of x. So, maybe it comes out to be a single value, no matter what may be the x value, it will be a constant. So, we can substitute any value to x and get that constant. So, when you know that some function is going to be a constant function, it is to get the value of that function or the range of that function, you give some value to the input. Okay, so we will give an easy value to it, put x equal to 0. If you put x equal to 0, this 3 into sin x minus cos x to the power 4, that part becomes just 3. 3 into 0 minus 1 power 4, that is 3. And the next second one, 6 into sin x plus cos x the whole square, is equal to, I'll get 6 into 0 plus 1 the whole square, that's again 6, and 4 into sine power 6x plus cos power 6x, that comes out to be 4 into 0 plus 1, that is again 4. So if you add this, or add all these three, what do you get? 13. But then this way of substitution method will save some time. That's why we are doing it. When can we do it? When we know that all the options are independent of x, meaning it's a constant, everything is going to be a constant. So that only in that circumstances you can go for a substitution method. It will save some time. Okay, so what we have here is, answer is 13. You can go by the conventional method of expanding and finding out sine square x plus cos square x equal to 1, and using some identities we can simplify it, but it would save time by making a substitution here. Right. So the answer is option 4 is the right answer. Option 4 is the right answer. Question number 8. If ABC are angles of a triangle ABC, then cos of 3a plus 2b plus c by 2 plus cos of a minus c by 2 is equal to, first option 0, second option 1, third option cos a, fourth option cos c. Now look here, as we have done in the previous question, we cannot always substitute because the options are not independent of ABC. So it's not advisable to substitute. So here what we do is we make use of the fact that a plus b plus c is 180. A plus b plus c is 180. 2a plus 2b plus 2c will be equal to 360. Okay. We will add and subtract a here. That makes it 3a plus 2b plus, we will take away 1c here and will then write it as c minus a is equal to 360 degrees. What am I doing here? This 3a I am writing it as 2a I am writing it as 3a minus a. This 2c I am writing it as c plus c. So now let's put this in the bracket here. Let us carry this c minus a the other side. So what do we have? 360 minus of a minus c. 360 plus a minus c. That's what you get. So 3a plus 2b plus c is equal to this. Now divided by 2, I will be getting this. Now what do you observe now? 3a plus 2b plus c by 2 is equal to 180 plus a minus c by 2. Now the cos of it will be cos of this. And what is cos of 180 plus theta? It is minus cos theta. So that comes out to be minus of cos of a minus c by 2. Now if I transpose it this side, I will therefore get cos of 3a plus 2b plus c by 2 plus cos of a minus c by 2 to be equal to 0. And therefore the right option is option 1 is the right option. Let's move on to the next question, question number 9. Cot theta plus cosecant theta minus 1 divided by cot theta minus cosecant theta plus 1 is equal to, first option 1 minus cos theta by sin theta, second option sin theta by 1 plus cos theta, third option 1 plus cos theta by sin theta, fourth option 1 minus sin theta by cos theta. Now cot theta plus cosecant theta minus 1 by cot theta minus cosecant theta plus 1 is what you have there. This 1 in the numerator, we will write it in the form of cosecant square theta minus cot square theta. So what you have in the numerator is cot theta plus cosecant theta, a minus of cosecant square theta minus cot square theta, that will make it plus cot square theta minus cosecant square theta. That's a numerator. Okay, so that divided by cot theta minus cosecant theta plus 1. Observe that you can take cot theta plus cosecant theta common here, because this is in the form of a plus b, this is a square minus b square. So we can take out cot theta plus cosecant theta common from the numerator, the two terms of the numerator, and therefore we get 1 plus cot theta minus cosecant theta. If you take out a plus b, you will be left with a minus b there. So now in the denominator we have cot theta minus cosecant theta plus 1, which is same as this part of the, so what you have is cot theta plus cosecant theta. Cot theta plus cosecant theta. This cot theta plus cosecant theta, now if you see the options are in terms of cos and sine. Therefore, let's convert this into cos and sine. Cos theta by sine theta plus 1 by sine theta. So taking sine theta as the LCM, what do we have? 1 plus cos theta by sine theta. Therefore, the right option is option 3 is the right option. Now let's make one small observation here. If you multiply this with multiply and divide by 1 minus cos theta, so what is it I would have got? I would have got in the numerator 1 minus cos square theta, that is sine square theta, divided by sine theta into 1 minus cos theta. So I could have cancelled out one sine theta factor. I would have got sine theta divided by 1 minus cos theta. Okay, so this is the right option. 1 plus cos theta by sine theta is the right option, but had he given sine theta by 1 minus cos theta, that also would have been correct. Okay, so both, I mean, you could have written it in the form of 1 plus cos theta by sine theta, or you can bring it into the form of sine theta by 1 minus cos theta. So both type would have been correct. Of course, we are not given this option, so we are only given this option, and hence we can go for option 3. Option 3 is the right answer. So let's move on to the next question, question number 10. If theta is not in the fourth quadrant and tan theta is equal to minus 4 by 3, it implies 5 sin theta plus 10 cos theta plus 9 secant theta plus 16 cosecant theta plus 4 cot theta is equal to, first option minus 1, second option 2 by 5, third option 4 by 5, and fourth option 0. Here we are given tan theta to be minus 4 by 3, and theta is not in the fourth quadrant. We know that tan is negative here and also tan is negative here. So when you say it is not in the fourth quadrant, so tan has to be in the second quadrant. Theta has to be in the second quadrant. So when theta, therefore the theta lies in the second quadrant. In the second quadrant, sine is positive, cos is negative. So here, if you form a right angle triangle, and we have here 4 by minus theta 3, because you know that sine theta has to be made positive. This is 5 units anyway. So sine theta is equal to 4 by 5. In the second quadrant, if theta lies, sine is positive and cos is negative. So here cos theta has to be minus 3 by 5. So substituting all these values now, what is sine? 5 sin theta? 5 sin theta will be 4. 5 sin theta plus 10 cos theta plus 9 secant theta plus 16 cosecant theta plus 4 cot theta. This is what you require. So let's plug in the values here. What is 5 sin theta? 4. 10 cos theta minus 6. 9 secant theta. Secant theta is minus 5 by 3. So 9 secant theta will mean minus 15. Okay, 9 into minus 5 by 3, that will make it minus 15. Plus 16 into cosecant theta. What is cosecant theta? 5 by 4. So 16 into 5 by 4. That is 20 there. Plus 4 cot theta. What is cot theta? Tan theta is minus 4 by 3. So 4 into minus 3 by 4. So what are we getting here? 4 minus 6 minus 15 plus 20 minus 3. That's clearly 24 minus 24. That's 0. Okay. Therefore, the right option is option 4 is the right answer.